Let's take a look at the idea of improper integrals. So far, everything we've always dealt with have been what's known as proper integrals. Now, recall the definite integral has a form, the integral from a to b of f of x dx. It requires that this interval a to b has to be finite. So a and b are real numbers. And the function f has to be continuous on the closed interval from a to b. Now, integrals that do not satisfy these properties are called improper integrals. Now, typically an integral is improper because of one or both of the boundaries are infinite, or there's a finite number of infinite discontinuities within the boundary. So as an example here, I'm integrating from 1 to infinity, and there's the problem. Infinity obviously is not a real number, so this is an improper integral. It's improper because the upper bound is infinite, and there's the problem. Now this one, we can see that we integrate from 1 to 5, and that's fine. That doesn't create a problem at all. But what is a problem is you can see that when x is equal to 3, this has an infinite discontinuity. So if you look at a graph of this, see 1, 2, 3, essentially it's going to look like this. And I have this issue here where there's a vertical asymptote. Well, that creates a problem when we try to integrate. So it's this type of scenario that we'll be looking at. We'll also be looking at, obviously, where I have an integral from infinity to maybe 3. That's of f of x dx. Well, this is the same scenario as here. Rather than the upper bound being infinite, now the lower bound is infinite. And of course, we also have situations where we may want to, this should obviously be negative infinity, go from negative infinity to infinity of some function f of x dx. Now both of our bounds are infinite, they're not real numbers, so I'm going to have to figure out something to deal with that scenario. So in a nutshell, this is what these next several videos will be covering.